What would happen if the world's most advanced smartphone turned into a space missile? Imagine this: an iPhone 17 Pro Max drifting silently through the vacuum of space at over 27,000 kilometers per hour, heading straight toward a $500 million NASA satellite. This isn't a scene from a science fiction movie. In orbit, even the smallest, most familiar object can become a devastating weapon. The iPhone 17 Pro Max, a marvel of engineering, crafted with aerospace-grade titanium, built for precision, and packed with cutting-edge technology. It's a masterpiece designed to connect us. But what if this very device somehow escapes Earth's gravitational grip? Maybe it's a phone lost by an astronaut during a spacewalk, or perhaps a payload from a test launch that went horribly wrong. Whatever the reason, it's now tumbling through low Earth orbit, and it's not alone. It has become part of a growing, invisible threat. In low Earth orbit, objects travel at a mind-boggling speed of roughly 7.8 kilometers per second. To put that into perspective, that's more than 10 times faster than a speeding bullet. At that velocity, even something as small as a screw has enough kinetic energy to puncture the hull of a spacecraft. So, let's consider the question: what happens when something as solid, dense, and sharp-edged as an iPhone collides with the delicate, complex structure of a satellite? NASA currently tracks over 27,000 pieces of orbital debris larger than a baseball, but there are millions of smaller objects, lost tools, fragments from old rockets, or a smartphone, that go completely undetected. These are silent, high-speed threats, waiting for a catastrophic encounter. Let's set the scene for our collision. Our imaginary iPhone is orbiting at an altitude of 400 kilometers above Earth. Its path is on a direct collision course with a vital communications satellite, one valued at $500 million. The angle of impact is 37 degrees. The relative speed at the moment of impact is a staggering 14 kilometers per second. At that speed, the energy released upon collision is equivalent to detonating a small explosive device. The iPhone's solid metal frame essentially becomes a high-speed, armor-piercing dart. As it strikes the satellite's vast solar panel array, it doesn't just bounce off. It tears through multiple layers of delicate photovoltaic cells and structural supports, sending a cloud of superheated shards flying in every direction. Each one of those fragments, from tiny pieces of glass to twisted bits of titanium, instantly becomes a new piece of dangerous space debris, each with its own destructive potential. The immediate impact is catastrophic. The collision instantly disables the satellite's critical communication systems. Its power levels drop to zero. On Earth, thousands, maybe millions of users suddenly lose their satellite connectivity. Within minutes, control rooms at NASA and private space companies light up with alarms. Operators detect the anomaly and scramble to assess the damage, but it's already too late. The satellite is dead. But the story doesn't end there. The shattered debris from both the iPhone and the satellite doesn't just disappear. It spreads out rapidly, creating an expanding cloud of shrapnel that continues to orbit the Earth. This new cloud increases the density of junk in that orbital path, making future collisions more likely. This is the textbook setup for a terrifying scenario known as the Kessler Syndrome, a cascade of collisions where debris from one impact creates more debris, which then causes even more impacts. It's a chain reaction that could, in a worst-case scenario, render entire sections of Earth's orbit unusable for decades, trapping us on our own planet. While our story of a rogue iPhone is fictional, the danger it represents is terrifyingly real. It highlights how even the tiniest, most seemingly harmless objects can wreak havoc in the high-stakes environment of space. A single, lost smartphone, drifting uncontrollably, has the potential to trigger a multi-million-dollar disaster with far-reaching consequences. This is precisely why space agencies around the world spend billions of dollars tracking space debris and developing strategies to protect their critical infrastructure in orbit. Space isn't a junkyard, but it's dangerously close to becoming one. If we don't get serious about managing orbital debris, A single, unfortunate accident could trigger a domino effect that impacts our GPS, our communications, and our ability to explore the cosmos. The future of our life in the space age depends on keeping our orbital highways clear. If you want to see more, what if space collision stories and explore the incredible physics of our universe, make sure to subscribe and hit that notification bell, because next time we're taking it even further. Thanks for watching.